Hi everyone, welcome to your own Essay Online Academy. Hope you guys are doing great. So I'm here with my another video. Let's start. So first we will look into our previous session quiz. Which technologies are used in the 2.4 GHz ISM band? So the answer to this question is all of the above. So FHSS was introduced in very first version 802.11 prime. HRD-SSS was introduced in 802.11b, and ERP is the alternate of OFDM, which is used in 5 GHz, and ERP OFDM is used in 2.4 GHz. So all technologies are used in 2.4 GHz ISM band. Question 2. In the Uni 1 band, what is the center frequency of channel 40? So friends, I explained to you how to calculate the center frequency of any uniband channel. If the channel number is 40, you just have to multiply channel number with the 5 and add 5000 in it. So channel 40 multiply it by 5 give you 200 and add 5000 into it, which gives you 5200, which is equivalent to 5.2 gigahertz. Question 3. The 802.11 2012 standard requires how much separation between center frequencies for HRD-SSS channels to be considered non-overlapping? So we discussed on this as well. 802.11 prime mentioned that 30 megahertz separation between center frequency, then it is called non-overlapping channels. But 802.11b introduced, and they defined it as separation of 25 megahertz between the center frequencies of two channels is known as non-overlapping channel. So the correct answer to this question is answer option B. So let's start with our today's agenda. Future Wi-Fi frequencies, 802.11 frequency band comparison, data rate versus throughput, adjacent and co-channel interference. So why future Wi-Fi frequencies? So the 2.4 gigahertz ISM band has remained the dominant license-free range of frequencies that has been used for Wi-Fi communication since 1997. Okay, although 802.11a was ratified in 1999, the use of 5 GHz unibands really didn't start to catch on until about 2006. So the major utilization of frequency band of 2.4 gigahertz is there, and after 2006, 5 gigahertz was catch the momentum and start getting used in Wi-Fi. And both these frequency bands are very much crowded these days, and the new applications like IoTs or high definition TV that are bandwidth intensive application like high definition TV and IoT requires a long range. So these applications requires a separate frequency bands to work perfectly for the respective applications. So that's why future Wi-Fi frequencies introduced. These are not very much used these days, but have seen as a wider scope of these frequencies in coming days. So first is 6060 gigahertz frequency band. The 802.11 AD ratified amendment defines very high throughput technology that will operate in the unlicensed 60 gigahertz frequency band. So 60 gigahertz frequency band, as it is very high frequency range band, so frequency is always inversely proportional to the wavelength and vice versa. So with the high frequency, wavelength is very small. So as wavelength is very small, it would not be possible to deploy it in a outdoor environment or an environment which requires a wider or longer coverage. So it it has a very high frequency band range, so it provides you a higher throughput. So this type of frequency band is used in indoor for intense bandwidth intensive applications. Okay, the new physical and MAC layer enhancements have the potential of accomplishing speeds of up to 7 Gbps. So it provides you a very high speed, so high throughput applications which requires high definition TV, that would be supported using this frequency band. Okay, I already told you the technology will most likely to be used likely be used to provide bandwidth intensive and short distance communications indoors, such as high definition video streaming. In September of 2012, the Wi-Fi Alliance designated the VGig certification to test interoperability of products that operate in the 60 gigahertz frequency band. Okay, so 60 gigahertz frequency band are not backward compatible with the 802.11 technology. So in 2012, Wi-Fi Alliance come with the VGig certification to test interoperability within this frequency band. They also come up with the idea, they define, like, we are using these days dual band radio wherein 2.4 gigahertz and 60 gigahertz work together. Okay, so if first user first latch to 5 gigahertz if it supports, then if not, then it will latch on a 2.4 gigahertz radio. So same way, this Wi-Fi Alliance, they come up with the idea of tri-band radio will have the capability to provide Wi-Fi access on 2.4 gigahertz, 5 gigahertz, and 60 gigahertz. This tri-band capability should provide for seamless handoff between devices in the short coverage area of 16 gigahertz band and greater coverage area of either 2.4 gigahertz or 5 gigahertz band. Meaning, you if user is within the short range, then it will be latched to 60 gigahertz frequency band. If it moves away from the AP, then it would latch to the 2.4 or 5 gigahertz frequency band. And they also introduced a VGig certification logo. When you see this logo on a device, then it is 60 gigahertz frequency band supported device. Okay, other future Wi-Fi frequencies sub 1 gigahertz frequency. So as compared to 60 gigahertz frequency band, which is very high, 1 gigahertz is the lowest frequency band up till now used in Wi-Fi. Okay, IEEE 802.11ah is a wireless networking protocol published in 2017 to be called Wi-Fi Hello. So hello is the name given to this sub 1 gigahertz frequency band. So it was defined in 802.11ah amendment introduced in 2017, published in 2017. The protocol's lower power consumption competes with Bluetooth and has added benefit of higher data rates and wider coverage range. So as I told you, wavelength is inversely proportional to the frequency, and frequency is inversely proportional to the wavelength. So here frequency is very low, so it has very big wavelength, so it can travel up to a distance of up to 1 kilometer. So this frequency band is used in application which requires a low power and wider coverage, like IoT applications or rural communication. So sub 1 gigahertz has a potential to be deployed for IoT application and rural communication. So sub 1 gigahertz RF operates in the ISM spectrum bands below sub 1 gigahertz, typically in the 769 935 megahertz. A benefit of 802.11ah is extended range, making it useful for rural communications and offloading cell phone tower traffic. The other purpose of the protocol is to allow low rate 802.11 wireless stations to be used in sub gigahertz spectrum. Okay, now let's have a look in and compare the major four frequency used in Wi-Fi. 2.4 gigahertz and 5 gigahertz you already know. Let's compare these existing 2.4 and 5 gigahertz with sub 1 gigahertz and this 6060 gigahertz frequency band. Sub 1 gigahertz was introduced in 802.11ah standard. 2.4 was introduced in 802.11 prime standard. 5 gigahertz in 802.11a standard, and 60 gigahertz was introduced in 802.11 AD standard. As I already told you, the phase frequency is inversely proportional to the wavelength. So lower the frequency is, higher the wavelength is. Okay, 33 centimeter highest, then 12 centimeter, 5 centimeter, and lowest is 5 mm, which is of 60 gigahertz frequency band. Higher the wavelength is, higher it travels the distance. So typical distance supported by sub 1 this frequency band is 1 kilometer for sub 1 gigahertz, 200 meter for 2.4 gigahertz, up to 100 meter for 5 gigahertz, up to 10 meter for 60 gigahertz. Congestion low, because right now sub 1 gigahertz and 60 gigahertz are not very much deployed, so they both are very less crowded as till now. And the highest crowded one you already know, because 60 to 70% of wi-fi deployments are in 2.4 gigahertz frequency band. Apart from wi-fi deployment, there are other applications which are using 2.4 gigahertz frequency band, like microwave ovens. So it is very much crowded one. 5 gigahertz are moderate, but now it is also getting very much crowded, because more and more wi-fi deployments are getting done in 5 gigahertz frequency band. Attenuation, the lower the frequencies, lower the attenuation is. Okay. And so sub 1 gigahertz lowest attenuation, then followed by 2.4 gigahertz, moderate for 5 gigahertz, and highest or very high for 60 gigahertz. That's why 60 gigahertz is for used for indoor application, because it is not possible for 60 hertz gigahertz frequency band to penetrate the wall. Okay. Lower the frequency is, lower the throughput is, because the channel width is small for these applications, these frequency bands. So the throughput is also very lower, and the modulation technique used is also has very limited functionality, so the throughput is very low. Sub 1 gigahertz are low data rate, 2.4 gigahertz is more moderate, 5 gigahertz high, 60 gigahertz is very high. Channel bandwidth 248 and 16 megahertz for sub 1 gigahertz, 22 megahertz. We discussed this about DSS and HRD Then 20 megahertz for 5 gigahertz, 2.16 gigahertz for 60 gigahertz. Use cases, it is used for IoT as I told you, and rural communication. 2.4 and 5 gigahertz for wireless or normal Wi-Fi right now going on these days. 60 gigahertz is used for HD or high definition applications. Industry acceptance, 2.4 and 5 are already very much well accepted by industry and deployed throughout the globe. So they have a high acceptance, low for sub 1 gigahertz and moderate for 60 gigahertz frequency band. So this is all about the major frequency band used in Wi-Fi these days. Let's discuss about a few important terminologies used in Wi-Fi and mistakenly use these words when we say that, like data rate and throughput. These two words are very much mistakenly used interchangingly in Wi-Fi, but they both have a different meaning, and they both are very much important when you're trying to explain something to your end customer. Okay, so let's have a look on these two terminologies: data rate versus throughput. So you went into market or you purchase something, and it is written on your device that it supports 300 mbps. You would say that, oh, it supports 300 mbps of throughput, but actually that is not the throughput. The throughput is always lesser than the data rate. 300 mbps is the data rate of that device. So while selecting your device, you should know the difference between data rate and throughput, because these two terminologies are very commonly interchangingly used in Wi-Fi. Okay, let's have a look. What is the term meaning of data rate and what is throughput? So if your data rate is if your channel support data rate of 1 gbps, okay, it is the maximum of amount of data that can be transferred through the channel. That is known as data rate, whereas the throughput is actual data transferred. So if your channel supports a data rate of 1 gbps, then it is not possible that it supports or it transferred actually the complete data only. There are many other things which get transferred. First is overhead information, like frame check sequence, your other informations, how your frames are placed, or your checksums, like frame management. These overhead information is also passed in your frame. So when you pass some frame over the channel, that channel has a speed of it supports a data rate of 1 gbps, although the actual data available in that frame is something 20 to 30% less than the total frame size. Okay, so throughput is now by default comes down from the data rate. Actual throughput is very less than the data rate. Then second point is that your Wi-Fi works in a half duplex mode. So it is not working in a full duplex mode. So it can either transmit or it can either receive. And third is your Wi-Fi medium is a shared medium, so you can't transmit all the time, you can't receive. So you have a multiple clients, you will get your, you have to be place yourself in a queue first. There are four clients. One by one each will transmit and receive the data, so your throughput, actual throughput is very less. If you use a legacy system like 802.11 abg, your throughput is almost 50% less than your data rate. In newer systems N or AC it is 30 to 40%, but still data throughput is always lesser than the data rate. So this is the throughput of one client. So even your channel has a data rate of 1 Gbps, throughput is 100 Mbps for one client. Okay, throughput, it is the actual data that transferred through the channel. So this is the difference between data rate and throughput, and you should be very clear while communicating with your client and while selecting your device what you are looking after, whether you are looking after for high data rate setup or device, or you are looking after for a high data rate through high throughput device. Okay, now let's have a look into two terms: adjacent channel interference and co-channel interference. 802.11 defined the term adjacent channel, which is equivalent to non-overlapping channel. So they have loosely defined this terminology. What they have said, any channel with non-overlapping frequencies are known as adjacent channels. But this term is very vague, and I would say very misused in today's Wi-Fi communication, because they IEEE defined this as they are not reusing the same frequency. That's why they are placed as a adjacent channel. But in actually, when we talk about adjacent channel interference, they defined it as when two or more APs, adjacent channel frequencies, overlapped each other, then it is called adjacent channel interference. We know in 2.4 gigahertz frequency band, channel 4, channel 1, 6 and 11 are non-overlapping. Rest other channels are play overlapping on each other frequency. So they are reusing the same frequency. So when they are reusing the same frequency, they are overlapping with each other and they are interfering. So this interference is called adjacent channel interference. Okay, let's have a look. So you can see AP1 transmitting on channel 4, AP2 transmitting on channel 5, and AP3 transmitting on channel 6. They are located very near to each other, so they are interfering in that frequency. Or their frequencies are overlapping each other. This overlapping or interference is called adjacent channel interference. So opposite to the IEEE definition, in which they have defined that non-overlapping channels are known as adjacent channel. As a adjacent channel interference is interference caused because of adjacent channel frequencies. Okay, the second one is co-channel interference. So interference caused by two co-located transmitter transmitting on the same channel is called co-channel interference. So in adjacent channel, what actually is happening, they are transmitting on adjacent channel frequency, they are not transmitting on the same frequency. So this different frequency is known as no, sorry, so this same frequency transmitting on the same frequency by two transmitter is known as co-channel interference. Let's have a look. Channel, there are two APs, AP1 and AP2, transmitting on same channel to two clients. Okay, so AP1 transmit on channel 6, and at the same channel AP2 transmit. So as they are very nearly located to each other or co-located within the same environment, their frequencies overlap, and this causes interference. This interference is known as co-channel interference. Okay, So you are now, I hope you are clear with this concept of adjacent channel and channel interference, because this is very confusing concept, and when you are deploying your Wi-Fi, you should be aware about the co-channels or the APs placed near to your deployment. Okay. So we are done with our today's session. Let's go to the quiz section. For HDTV, which frequency band is used? Sub 1 GHz, 2.4 GHz, 5 GHz, or 60 GHz? Which of the following statement is true for data rate and throughput? Option A. Data rate and throughput is always same. Data rate is double than throughput. Throughput is one-fourth of data rate. Throughput is always less than data rate. Interference caused due to overlapping of adjacent channel frequency is known as what? Co-channel interference, overlapping channel interference, adjacent channel interference, co-location interference. Okay. So friends, we are done. Thanks for your time. Be ready with the answer. We will discuss on answers in our next video. Please don't forget to like, share, subscribe, and comment on my video. Thank you.